All right, cool. So I've started. Sweet. Let's just go right into it then. So you're talking about number 2?
Yeah.
Which part of number 2?
D. The last
D.
one.
That one. Oh yeah, that one was a weird one. So what I got. I mean, the funny thing is, it's not actually a question. It doesn't actually ask for anything in it. So I assumed it was asking for like the different probabilities of each one, but it never actually asked for anything in the question. So, but I don't know. What you guys get?
I got 0.069%.
Okay, that's what I got too. Yeah.
How'd you get them?
So I just like, what'd you get for the probabilities of each phenotype? Did you get 9331?
Sure.
9 out of 16, 3 out of 16.
Mm-hmm.
And so then you just go through and just times each one. Whatever it asks for, just times it by the next one.
Oh, okay.
Yeah.
So it's like 9 over 16 times 1 over 16 times 3 over 16.
Oh,
Does that make sense?
Yeah, that makes sense.
Okay. For number 1, what did you guys get for 1B? I got 14%.
Yeah, 17.8.
17.8. Okay. I'm trying to remember how I solved for it. I don't know where I wrote it down, but do you know how you solved for it?
Yeah. The probability of getting ground yellow seeds is 9 out of 16.
Mm-hmm.
But you have to get that 3 times in a row.
Yeah.
So I just times that straight across.
Okay.
So it came out to like 729 over 4,096.
Yeah. Oh, okay. Yeah. Yeah.
Makes sense.
Yeah. I know what I did now. I did the binomial expansion formula, which I think I feel like it should be the same though, because it's calculating the same exact thing. But okay. So you got 17. I honestly don't know which one is the right answer. If it's because I would think that you could just multiply the 3 together and that would give you the result, rather than using another formula.
That's what I assumed. It's like you can't do that.
Yeah. Okay. Well, that's something we could put on.
I was trying to use that binomial expansion.
Yeah.
But like, you have to do like x minus n or whatever, right?
That is.
Or is
that's for the other one. The other
the chi-square.
Yeah, the chi-square test. No, the binomial expansion is just like you just need to know the number of like total events and then like the probability of one of the types, and that's really it. But that's something we could put in as like one of our questions in our like, group thing when we actually post the video. Yeah. Okay. So I'm gonna write that down so we can put it in there.
This one right here you're talking about?
Yeah, that's it.
Because you have the n minus x, right?
Yeah.
Wouldn't that be? Because I was like.
So it cancels out.
Yeah, it's 3. So take it to 0. So I was like, how would you like divide by 0?
That was my question too.
So
but
I didn't even try it.
Yeah, I don't really know either. And that was my question with it too. But so I'm guessing he probably has the right answer then, because otherwise that really wouldn't make any sense. Okay. Cool.
Did you get wait, were we talking about this one before? 1C.
1C. Yeah, that was the other one.
What did you get for that one?
That was the one where I got 7/16. I don't know how I got it or where I got it from, but that was the one we were talking about earlier. Let's see here. Where did I put it? Round. Yeah, I see it's one equilibrium. Um, 3, 6. So for that one, okay, I know what I did there. So with that one, what I got for the probability for round and yellow is 3/8. Did you get that?
Round yellow.
Yeah.
No, we got 3/4, right? 9/16.
On C?
Yeah, just for round yellow.
Yeah.
1, 2, 3, 4, 5, 6.
Well,
Yeah. That's about 9/16.
Okay. I think, yeah, that's what I did. I added wrong. It was fine. It's the same answer then.
so for number 2, I guess I can just go through what I got. So
Okay.
you guys gotta see. I got like 10%, not 10% for A. Anybody get close to that?
No. So for 2A, I got 14.1.
How did you do that?
So it's the same thing that we were just talking about, where I tried to use the binomial formula for each one, but I think you're right in that like it wouldn't make sense because it cancels out in the formula. So
Gotcha. I don't even know if I did it right. So I'll have to like watch your video.
yeah,
Just what did you get for that one?
Just don't even. Probably got it wrong.
okay.
I feel like it's more likely you guys get the right answers than I do.
I guess B, I got it was like 0.39%. C like way small, like 0.0001%. What did you get for C?
Something way different. I got 65%. And so okay, so this one again, I used the binomial formula again with that one. And what I did is I did it for each. I did it for the 3 tall and white, and then I did the formula again for the 4 that are short and white. And then I just can't remember if I add or multiply the 2 together.
I was just thinking this one has to be like way small because
I would think it probably would be.
you guys asked me for like tall with white, which
Yeah.
is which has the recessive white, and then dwarf with white, which is recessive.
Yeah.
And like getting that 4 times, it's gonna be like super unlikely, you know?
Yeah.
So I was thinking it has to be like really small.
What was the percentage that you got?
Like 0.00001%.
Okay.
But yeah, I don't know.
Okay. Oh, so you just took the probability of each happening and just multiply them 7 times. Oh, okay.
Well, so I did the probability of tall white 3 times and the probability of
And then just added that to the.
dwarf white 4 times.
Okay. Yeah.
But I mean,
Okay. So yeah, it just goes back to the question of like, do we use a binomial formula or is it? Yeah, that's really what it
We'll just
is.
have to wait on those.
Yeah. Sweet. Well, yeah, this is the only one that I didn't.
I can
Finish.
show you what I did. So for the null hypothesis,
Yeah.
I put disease sensitive and herbicide resistant occur at a 3-to-1 ratio. And that I just got that from adding everything up. So there's 214 disease sensitive and herbicide resistant.
Yeah.
And only 74 disease resistant and herbicide sensitive. Gives you a total of 288. And so then if you just do the chi-squared,
Oh, okay.
it comes out to 0.075. And then I just looked up the like the p-values on that PowerPoint.
Yeah.
And it fell within like an acceptable range. So like on C, we'd accept the null hypothesis.
Is that that chart?
Yeah, like if it lies in the
It's
dark
like-
green area.
Yeah, it's like that one right there.
Yeah.
Okay.
So then I just found where like, oh, and then you go with like degrees of freedom, and that's just based off how many rows and columns you have minus
Yeah.
1. And so there's only 1 degree of freedom.
Yeah.
And so the null hypothesis was accepted.
Okay.
So that wasn't too bad. You just had to like go through the chi-square.
Yeah.
Same thing with like 5. It's kind of similar.
Okay. Sweet. Shouldn't be too bad then. All right. So let's just go through the pedigrees really quick. First one I got autosomal dominant. Do you guys get that? Yeah. Okay. And next one I got X-linked dominant.
That's what I got.
Okay. Sweet. And then X-linked recessive. You guys get that too?
Wait for C.
For whichever the third one is.
I
1,
thought
2,
that
3.
was Wiley. Just because it was like.
Because it was all male.
Yeah.
Well, but,
But I thought if it's Y-linked, all the males would have it, right? Because
yeah. So it would be
Oh, is
recessive,
Is that
X-linked recessive.
with
Or-
X-linked recessive, it would skip around, but it'd be
All
most
sons.
males who would have it.
all sons of affected fathers? So what was it?
X-linked recessive.
Trying to
Yeah.
I just like saw this like all male like that.
Yeah. That one threw me off at first too. Okay, and then the last one I put autosomal recessive. Everyone get that too? Yeah. Sweet. Okay. Cool. Okay. So these ones, the next few were touched like the 20th century dude, the mice and all that. So that one is the one like, I was just working on just now. And I think the only thing for me, I just didn't quite understand how to use the chart for the chi-square thing to do the probabilities or whatever. So I got a value, I just didn't know. Like,
What do you get for your value on A?
where did I put it? Sorry, let me just figure out where I wrote it down. So the X value I got ended up being 2.338. Is that what you got?
No, I got
No.
1.257.
1.257. Okay. So how did you get
Do you
that?
have like your numbers of like your expected and
Yeah. So
and stuff?
yeah. So this is what I got. So because this is a 3-to-1 ratio, right?
Yeah. So the way I figured out what my expecteds were is
Mhm.
like, so 3-to-1 ratio, that means it's
Yeah.
75% of this,
Yeah.
25 of that. So I
Yeah.
take this number, times it by 70.75,
Okay.
gives you that.
Yeah.
Times it by 0.25 gives you this.
Yeah.
And since that equals up to 100%, these numbers still equal 363. So
Okay.
that's what they got. But then the expected is based off that ratio. Like that's the
Yeah.
exact expected number.
Gotcha.
Then I just plug that into this right here, the observed minus expected
Okay.
over expected squared.
Yeah.
And came out with that. And this is the only one that you can't reject. The B and C, like you reject because the number is like way high. Yeah, and didn't follow in the chart.
Okay.
Does that make sense?
Yeah, that makes sense. Okay. So then I think what I did then is just calculating those initial numbers. I just
Yeah.
got the wrong value. Then.
Yeah,
That's
I
it.
calculated off, yeah. And then on D, I just put the inheritance follows more of a 2-to-1 ratio compared to the suggested 3-to-1 based on the data collected.
Yeah. Okay.
So it seems to follow.
Cool. Okay, so that's really not too bad of a fix then.
Yeah.
All right. Cool. Well, does anyone else have anything? Well,
Is that cool with that?
yeah, sweet. It's all good.